Uranus, the icy giant of our solar system, is a place where temperatures can plunge to a staggering minus 370 degrees Fahrenheit. That's colder than any other planet. This frigid atmosphere is composed mainly of hydrogen and helium, with a hint of methane, giving it that striking bluish-green hue. Interestingly, Uranus spins on its side, making its axial tilt a jaw-dropping 98 degrees. Imagine a planet rolling through space like a giant bowling ball. Its unique tilt leads to extreme seasons, with each pole experiencing 42 years of continuous sunlight followed by 42 years of darkness. And let's not forget its rings. Faint but fascinating, they add to the allure of this distant world. Uranus is not just cold, it's a captivating mystery waiting to be explored. Uranus, the enigmatic giant of our solar system, is a planet that truly stands out. Discovered in 1781 by Sir William Herschel, it was the first planet found with a telescope, orbiting the Sun at an astonishing distance of about 1.8 billion miles. Imagine that. 84 Earth years to complete just one trip around the Sun. What's even more fascinating is its extreme axial tilt of nearly 98 degrees, causing it to roll through space like a giant bowling ball. This unique tilt leads to bizarre seasonal changes and gives Uranus its distinctive look, with rings and moons moving in unexpected ways. And let's not forget the temperatures. Uranus is one of the coldest places in our solar system, with frigid winds that can reach up to 560 miles per hour. A true ice giant, Uranus is a world of wonders waiting to be explored. Uranus holds the record for the coldest atmosphere in the solar system. The planet's outer atmosphere can plunge to a mind-numbing minus 224 degrees Celsius, minus 371 degrees Fahrenheit. But how does Uranus get so cold? The temperature on Uranus is a result of several factors, including its distance from the Sun, its composition, and its unique atmospheric processes. The planet is composed mainly of hydrogen, helium, and a small percentage of methane, which gives it its characteristic blue-green color. However, unlike other gas giants, Uranus lacks a strong internal heat source. Let's take a closer look at the internal heat of gas giants. Jupiter and Saturn, for example, emit more heat than they receive from the Sun, thanks to the heat generated by the slow gravitational compression of their interiors, a process called Kelvin-Helmholtz contraction. Neptune, Uranus's icy twin, also emits a significant amount of internal heat. But Uranus is an exception. It barely emits any heat at all. In fact, the temperature difference between its core and outer atmosphere is unusually low, which is why its atmosphere is so cold. Scientists believe that at some point in Uranus's history, a cataclysmic collision with a massive object could have knocked the planet on its side and potentially caused it to lose most of its internal heat. Uranus's extreme axial tilt doesn't just affect its appearance. It also leads to bizarre seasonal changes. Each pole gets about 42 years of continuous sunlight followed by 42 years of darkness. But even during these long summers and winters, the temperatures remain frigid. During the summer, when the sun shines continuously on one pole, you might expect the temperatures to rise. But on Uranus, the sun's rays are so weak due to the planet's distance from the sun that they barely warm the atmosphere at all. This results in minimal seasonal temperature variation. Uranus's atmosphere is divided into several layers, each with its own characteristics. The outermost layer, called the exosphere, extends thousands of kilometers into space and is composed mostly of hydrogen and helium. Below it lies the thermosphere, which, despite its name, is incredibly cold. The lower layers, the stratosphere and troposphere, contain methane ice clouds. These clouds are responsible for the faint banding visible on Uranus. But unlike Earth, where the troposphere is where weather happens, the weather on Uranus is almost non-existent due to its low energy levels. However, when storms do occur, they are swift and powerful, despite the generally calm atmosphere. These storms, detected by the Voyager 2 spacecraft and later by the Hubble Space Telescope, appear as bright white clouds against the blue background. However, they are not driven by the same mechanisms as storms on Earth. Instead, they are likely the result of upwelling of material from the deeper layers of the atmosphere. So, why exactly is Uranus colder than Neptune, even though Neptune is further from the Sun? The answer lies in the internal heat, or lack thereof. As we mentioned earlier, Uranus does not have a strong internal heat source to warm its atmosphere. In contrast, Neptune emits more than twice the heat it receives from the Sun, which keeps its atmosphere warmer than Uranus's. Additionally, Uranus's axial tilt might contribute to the suppression of its internal heat. The tilt could have led to a more uniform distribution of any remaining internal heat across the planet, preventing the buildup of significant temperature differences. This theory, however, is still under investigation by scientists. Uranus, a mysterious giant of our solar system, has only been glimpsed through the eyes of Voyager 2 during its flyby in 1986. This encounter unveiled a world of faint rings and intriguing moons, but the secrets of its bizarre atmosphere remain largely untouched. Imagine the possibilities if we could send a dedicated mission to this ice giant. Scientists are eager to dive deeper into its swirling clouds and complex magnetosphere. Understanding Uranus could unlock the mysteries of not just this planet, but also the ice giants scattered throughout our galaxy. The quest for knowledge continues, and Uranus is calling us to explore its depths. Uranus is surrounded by a system of 27 known moons, each with its own unique characteristics. The 5 largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are particularly intriguing. These moons are composed primarily of ice and rock and experience extreme cold as well. Take Miranda, for example. This moon has one of the most varied and bizarre surfaces in the solar system, with cliffs towering up to 20 kilometers high, canyons, and chaotic terrain. Despite this dramatic landscape, temperatures on Miranda are estimated to be around minus 187 degrees Celsius, minus 305 degrees Fahrenheit, making it one of the coldest places in the Uranian system. Similarly, Titania and Oberon, the largest of Uranus's moons, are also incredibly cold. Their surfaces are covered in water ice, which remains frozen solid at temperatures as low as minus 203 degrees Celsius, minus 333 degrees Fahrenheit. Understanding these moons could provide insights into the conditions on other icy bodies in the outer solar system. Another fascinating aspect of Uranus is its magnetosphere. Unlike Earth, whose magnetic field is aligned closely with its rotational axis, Uranus's magnetic field is tilted at an angle of 59 degrees relative to its axis. This means the magnetic poles are located far from the geographical poles, resulting in a magnetosphere that wobbles as the planet rotates. This unusual configuration creates a magnetosphere that is both unique and complex. The interaction between Uranus's magnetic field and the solar wind results in a magnetosphere that behaves differently from those of other planets, with fluctuating auroras and a highly variable boundary between the planet and space. Interestingly, the magnetosphere may also play a role in the cold temperatures on Uranus. The interactions within the magnetosphere could influence the movement of particles in the upper atmosphere, contributing to the overall cooling effect. Uranus, the ice giant, remains one of the most mysterious and intriguing planets in our solar system. Its extreme cold, unique axial tilt, and lack of internal heat make it a fascinating subject of study. While we've learned a lot from the Voyager 2 flyby, there's still so much more to discover. As we look to the future, the exploration of Uranus could unlock secrets not just about this distant world, but about the formation and evolution of our entire solar system. Who knows what surprises await us on the coldest planet in our cosmic neighborhood? Thank you for watching. If you enjoyed this deep dive into the frigid world of Uranus, be sure to like, share, and subscribe to Amazing World Facts for more incredible insights into our universe. And as always, stay curious.